Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So now let's move to chapter 2, part 1. That is DC circuit. So in this chapter, part 1, you will learn about resistor, Ohm's law, conductance and power. So for this chapter 2, you will learn about what we call Ohm's law. What is the difference between nodes, branch and loops, Kirchhoff law, series resistor and voltage division, parallel resistor and current division. Okay. Now, what is resistance? So, if you see in this figure, we have a lot of resistor here. So, this is what we call resistor, and what is actually that? So, in the last chapter, you learn about voltage. So, what is voltage? So, voltage is the potential difference, right? So you need the analogy. If you remember, there is a waterfall, so we have VAB, right? So it's a potential difference between high and low. Now, what is current? So current is the movement of the charge over the time. So in order for you to have the current, you need to supply the voltage, so then the current can flow in the complete loop. So in a circuit, there is what we call resistance, where it will limit the current flow. If you see this analogy here, the voltage is pushing forward the charge towards to your right, but this hand, that is what we call here resistance, will push away the charge to limit the charge to move down to the y side. Okay, so it limits the current flow. Now, what is actually resistance? So just now, in order for a circuit to work, so let's say this is a circuit, you have a power supply, you have a resistor. So in order for you to connect this supply to the resistor, you need a wire. So this wire we call a conductive wire. So inside the wire, it need to have what you call, is a material, right? So the material need to be conductive. So this wire is having this area and also the length of the wire, and how you calculate the resistance. So R here, what is called resistance. Now look at the rho here. Rho here is the resistivity of the material. So means if this is the material of the copper, it have their own resistivity. If you change the material, you will have different resistivity denoted by rho. Now the length is also matters. So the higher the length, the higher the resistance. So this is proportional, right? And if we divide it by this area, so means the smaller the area. Okay, so if we see here, there is a two comparison here. The first one is the thicker and the second one is the longer wire. So for the thicker wire, we are depending on the area, right? So the wire S is having the smaller area, wire T is having the bigger area. So what is the relation between the area and the resistor? It is inversely proportional. So means if the area increase, the resistor will be smaller. So that's why here we have a lower resistor. Now, what is the relation between the long and the short wire? So if you see the relation here, R and L, there is a proportional, right? So means the longer the wire, the higher the resistance. So this is the relation between the resistivity and the area and the length. What is rho here is the depend on the material. So R here is the resistance, but rho here is what we call resistivity. Okay, so this is the most simplest element for the resistance. Okay, so this is, as I mentioned just now, the rho. So the rho is depend on the material, right? So if you see here, different material has different resistivity. So if this is a conductor, so this is the resistivity until the gold here. So the resistivity here is around 1.6 until 2 multiplied by 10 power of minus 8. But semiconductor is having different resistivity and also insulator. Okay, so next, what is Ohm's law? So just now you learned about resistance. So now we are going to find the relation between V and I. So Ohm's law is saying that the voltage across a resistor. So here you have a resistor. The voltage across the resistor will be directly proportional to the current. So now you have a resistor. So what is the voltage across the resistor? Will be proportional to the current flow through the resistor. So V and I here will always be proportional, means the higher the voltage, the higher the voltage, the higher the current that will be passed through the resistor. So how you denote the notation here? So V is proportional to I. So if you change to equal, it becomes some, you need to introduce some constant, right? I. So what is the constant here is what we call the resistance. So V equal R multiplied by I, or usually we call here IR. So this is what we call Ohm's law. So what is R? R is the resistance, is V over I, and it denoted by the ohm. The resistance, the ohm, right? It measured by ohm. So what is actually resistance is the ability to resist. It block the current to reduce the current flow. Okay. So now for a resistor, so there are two types of resistor. The first one is the fixed resistor, where the current remains constant. So the one that you can see in the lab later. So there's many color here. So maybe this one is 220 ohm. So this one we call fixed resistor. So we have another one that is what we call potentiometer. There is 3 pin here where you can adjust the resistor maybe between 0 until 1 mega ohm. Okay, so just now we say that V is proportional to I, right? So it is a line graph. So when you increase your voltage, your current will also be increased. So the slope of this graph is, how you find the slope? Is delta Y, is V here divided by delta I. So what is V over I is actually your R, your slope here. So not all resistance are linear. So this is what we call linear graph. But there is some resistor that is non-linear like this. So for Ohm's law to works, Ohm's law only apply at a linear resistor. Ohm's law cannot apply at the non-linear resistor. Okay. So this is just the same explanation. So means only material with a linear relationship. That's what is PSP? The passive sign convention means the current will flow to the positive, from positive to the negative. So this is what PSC is all about. So Ohm's law only apply at the linear and will not apply at the non-linear resistor. Okay, so if you see this analogy here, you are going to supply the voltage. The voltage is trying to push the current to the other side, but there is one resistance that limit the current to flow directly. So how the relation goes? V equal to IR, I equal V over R, and R equal V over I. So there are two extreme conditions for the resistor. So the first one here is R equal to 0. R equal to 0. The second one is R equal to infinite. So what does this mean? So if you see here, R equal to 0, if you see the analogy before, there is no resistance here. There's no one who limit the current. So the voltage can easily flow the current, right? So it's like a free highway here. So there will be no voltage drop. Since there is no resistor there, so there will be no voltage drop. So we call this one short circuit. It's like a highway short circuit. Okay. But what will happen when R equal to infinite? Infinite means what? Infinite means very high. Very high. So go to this analogy again. So you have a voltage trying to push the current, but your resistor here, it tight here very, this one is very tight, so the current will be difficult to go to the other side, right? So means it will goes almost to no current, I equal to 0, because this is not a highway. We call this like a village road. There is so many resistance in between, and even the current cannot flow through. So this one no current means I equal to 0. We call this one open circuit. So open circuit will happen when R equal infinite. Short circuit will happen when R equal to 0. You imagine this one is like a highway. Okay, so this is more explanation here. So if you have a short circuits, means there is no voltage drop here. It is 0 volt and current can easily pass through. So this is happen when R equal to 0. But when R is very high, it goes to infinite, so the path seems broken because it blocked, right? Remember, our resistance limits the current. So now here become open circuits. So this is the concept. Okay, now what is conductance? Just now we are talking about resistance, that is V over I, right? So now what is conductance? Conductance from the name is it able to conduct the current. So is equal to G equal 1 over R, means it is inversely to the resistance. So resistance means limit, right? Limit the current. G is means conduct the current. So let's look at the unit. So resistance here is ohm. So now it become 1 over ohm, or we call this one Siemens. Siemens or S. Okay. Okay, next power. So we know that the power from chapter 1 before. So this is the formula IV. So you know V is equal to IR. So you can get power also equal to I square R. Or you change here IV. So you know I now is equal to V over R. So you just multiply together. We become V squared over R. So your power is having two units, two formula. I square R and V squared over R. Okay, now let's calculate one circuit. So this is you need to determine the voltage, conductance and power. So you are given a current source 2 milliampere. There is a resistor of 10 kilo and the current flowing through the positive according to the passive sign convention. So what is V? You know V is equal to IR. So I is the current source here is 2 milliampere multiplied by 10K. So you can get here 2 volt. Okay. So what is the conductance here? G. G is 1 over R, means 1 over 10K. So 1 divided by 10K, and then you can get 0.1 milli. So the unit is Siemens. Okay. So the last one, what is power? Power is VI. So what is the voltage across this 10K is 2 volt. And what is the current across the 10K is 2 milliampere. So you can get around 4 milliwatt. Sorry just now. So this one is 20 volt, right? Sorry for that. Okay, so this is 20 volt. So here you can get 40 milliwatt. So the unit is watt. So for this example, you can try by yourself, and then we will discuss more example in the class later. So that's all for the first part of chapter 1. Assalamualaikum warahmatullahi wabarakatuh.